and put on its symmetry. Symmetry. Anybody know what lines of symmetry are? We've done this before. Rena? I didn't actually hear what you said. A line of symmetry cuts a shape in half so that each half is a mirror image of the other. And again, we've done this many times before. You just have to be a little careful with it because what's sometimes you think is obvious is not obvious. For example, if you have an isosceles triangle, where would you draw a line that would split it in half, but that would make each side an exact mirror image of each other? This would have just one line of symmetry right down the middle here. Because when you fold those on top of each other, these two halves would match up point for point. Okay. If by some chance it was an equilateral triangle, that has how many lines of symmetry? You could take it and you could split it like this. You can split it like this, and you can split it like this. All of those you could fold over top of each other and get a line of symmetry and it would match up. If it is a rectangle, Mitch, how could I split this? Oh, here's a good example. I not have a piece of paper. Well, I do have one. Here's my rectangle that I start off with. How could I fold it / what line could I put on it so that it becomes identical parts cut in half? Well, I've already done this one. This would be a line of symmetry. See how the line sides match up? So you know this is one. Right down the middle. Another line of symmetry it would have is, Riley? Horizontally, which would mean this. Down the middle, do those sides all match up? They certainly do. Another line of symmetry. Mitch?
From one corner to the other.
Now, let's look at that, because like I said, what seems obvious isn't always. Here I go. I got my rectangle. I go from one corner to the other corner. Do those sides match up when you do side to side, corner to corner? Diagonals are not lines of symmetry on rectangles. They are lines of symmetry on squares, though. Here's my square. If you have a square, and I will tell you what, I will try to rip this so it is a square. I have to do this to be a square. 8.5 by 11, cut off what? 3 inches. 2.5 inches. I missed. On a square, though, if you fold it on its diagonal, wait, I missed. Hold on. Let's fix it. A square does have a diagonal line of symmetry because as you fold it, the sides do match up with each other. Not the rectangle, but the square does through here. Now the ultimate question is, how about a circle? How many lines of symmetry does a circle have? Maddie?
A lot.
Yeah, a lot would be the best answer because any place, any diameter that you draw through there, that circle could be cut in half through that line. There's an infinite amount you can never count because you could just keep drawing more and more and more. Something that looks like this. What about a rhombus? Line of symmetry on a rhombus. If you drew a horizontal one and folded it, would the corners match up with each other? They would not. If you drew something like this, would they match up? I don't believe they would either. If you did diagonals, I don't think a rhombus has any lines of symmetry. I'd actually have to do that. Now, with that being said, we also have one more type of symmetry, and write this down. We have what's called rotational symmetry. And rotational symmetry, so much. Rotational symmetry is that when you rotate, when you spin, comma, do you get the exact shape, here's the key, before you spin it 360 degrees side. And I'll explain it. It'll make more sense when I do it, I hope. That means this, children. Okay, here's my same shape. Okay, this would have rotational symmetry if, as I rotate this, do I ever come up with this exact same shape and the same thing before I spin it all the way around? Because obviously, when you spin something 360, you end up with the same thing. So you'd sit here and you'd go, okay, is that the same shape? No. Upside down the same shape? No. That the same shape? No. That the same shape? Yes. So does this have rotational symmetry? That's a big fat no. But if my triangle was this, let's say I've got an equilateral triangle. If you have an equilateral triangle, if you spin it just one time that, which is a third of a turn, same shape. Yes, rotational symmetry. Again, you spin here, same shape, and spin it there. This is yes. Something fun to try are like letters. Let's say I've got the letter H. I'll try to do this in one big line. Does the letter H have rotational symmetry? Does it end up being the letter H before I spin it all the way around? Well, certainly not there. But is that the letter H? Yes. Does this have regular symmetry? How many lines of regular symmetry would it have? Just two, horizontally and vertically. What else do they ask us? How about a rectangle? Does a rectangle have rotational symmetry? Yes or no? If you spin it just 180, is it the same rectangle? Yes, so yes it does. Mrs. Stone,